The premise for this video is to help characterize return path and identify quickly if there is an ingressing culprit, and to help isolate which node this interference is coming from, and ultimately from which return leg of that node. For this test, we will be using both the 80 dB dynamic range spectrum analyzer and the digital persistence spectrum function found in the DS2831. The digital persistence spectrum function is based on fast Fourier transform technology, more commonly called FFT, with fast processing, and enables in-service detection of nasty transient noise and impairments, linear or nonlinear, hiding underneath upstream bursty signaling, like with bonded DOCSIS 3 upstream channels or with DOCSIS 3.1 OFDMA signals. If the field technician uses a typical RF sweeping spectrum analyzer, there are several ways to capture ingress and RF energy. Essentially, you have the ability to display simultaneously multiple traces differently processed through the spectrum analyzer's circuits, with min, max, average, and live traces. The sum of those accumulated traces don't typically give you the ability to see below the desired signal, essentially masking any undesired RF energy, as shown in the figure. In contrast, when switching to the DPS function, impairments like CPD and impulse noise can be easily captured and then displayed with a color-coded spectrum density display like the one shown here. In comparison, the spectrum analyzer DPS settings in this example are identical to those of the previous figure, except for the time sweep setting, allowing for more FFT acquisitions since upstream traffic was low in this example. Spectrum persistence testing captures multiple wideband FFT signals in a user-determined sweep time. The sweep speed of each capture is determined by the span setting used by the field technician. Unlike a typical spectrum analyzer sweep function, where signals are simply accumulated one after the other, the DPS function overlays each FFT capture. This allows some of the FFT scans to capture the RF signature where the desired signal is not transmitting, then revealing the noise floor below and an undesired impulse noise or linear distortions that might be hiding below. Once the sweep time resets, multiple FFTs will have been overlaid, one over the other, thus showing both the desired and undesired signals simultaneously. Depending on DOCSIS traffic, best results usually call for 1,000 to 2,000 milliseconds of sweep time, allowing the DS2831's processor to accumulate FFT captures and displaying the relevant details about the overall RF signature of the occupied spectrum. When looking at the overall RF energy and displaying it all as a series of bitmap points rather than a swept trace, typically only revealing parts of the RF signature. In other words, it's a graphical representation of RF energy, and the color of the bitmap will depend on the percentage of RF signal occupation. For each bitmap point is a set sweep time. More signal presence at a given bitmap location will signify heavier RF density over that bitmap screen location, hence hotter or redder in this case. But when less signal presence is captured during the acquisition period, the bitmap will be cooler, or bluer in this case. This picture represents a DOCSIS 3.0 upstream transmission and clearly shows what the differences in signal presence make. The colors assigned to bitmaps across the capture bands are hotter as more signal presence is detected. Up to 200 MHz can be set to capture in this mode. We cannot say enough about the importance of having both the DPS function and a true spectrum analyzer, which will provide the ability to view much deeper into the CATV network. In the case of this picture, great analyzer sensitivity combined with DPS technology will reveal downstream signals being reflected onto the upstream spectrum, more commonly known as CPD. Because no analog channels were being transmitted, this is digital CPD. Now let's look closer at the recommended approach to isolating the impairments. Because of the high analyzer sensitivity, the DPS picture is able to show a more detailed digital signature of the reflected downstream signal, down to about -63 dBmV, as opposed to viewing through a signal level meter device, which would simply show a slightly elevated but flat noise floor. The first step is to start at the head end, where all of your optical return path receiver test points are in one location. Going from one test point to the other, you can quickly identify if a node is healthy or not. Usually this exercise is quite simple, since most MSOs already have a good idea which nodes show poor customer experience or signal performance. This picture shows a typical healthy return path noise floor. The objective is to hunt return path test points, typically optical, that are having difficulties, and that is very easily confirmed with a visual inspection. This picture shows a typical OFDMA signal transmission with a very low and short linear distortion. Once a node with difficulty is identified, start by saving this trace for later field comparison use. The technician can then move to the specified node in the field to isolate the impairment location. Now starts the ever so critical and timely work of identifying which of the 4 return path test points is the culprit. By opening the front panel of the node or by accessing a node external test point where each return is available for testing, the technician can easily go from one RF port to the other, all at the same time visually inspecting the picture that most resembles the picture saved back at the head end. Once the correct return path is identified, the field engineer or technician can more easily spend quality time to go down the particular return path line and isolate where the impairment is. The last step is to go down the line from the node to the first active, then to the next active, until such time the distortion is no longer visible. This means that the impairment can then be properly identified as present between the last test point verified and the one before it. This can easily be stated as the quickest method to identify which node return test points require attention and further field troubleshooting. Thank you for watching this video. If you need to reach us, please send us an email.